So following on from the previous video, we were trying to work out the area between 0 and 2 here. We were trying to work out this area here. Okay, now we can use these three here to help us find out the area now. So remember, k to the power of 3 equals this, k squared equals this thing here, and k here equals this thing here. So so now, hang on. So we got to this stage here. So blah blah blah. Hang on. We got to this stage here where we recognize that this here is a constant. We can take it out. This here is a constant. We can take it out. This here is a constant. We can take it out. That will allow us to concentrate on finding out the sum of this, the sum of k squared, the sum of k here. So now we can use the formula from earlier to substitute in here. So this thing here is this thing here. Okay, so there's a formula that allows us to jump from here to here, and then there's a formula that allows us to jump from here to here, and there's a formula that allows us to jump from here to here. Okay, so it's just us using the formula, and we've done this before in one of the early videos. Okay, so this whole thing here becomes this whole thing here. Okay, and then hang on, and then what? And then hang on, let me think. And then and then this times this times this. That will allow you to get to here. And then it's and then multiply this out. This times this times this, and then this times this times this will give you this whole thing here. Okay, and then 6 divided by 2 here. That will give you the 3 here, and the 2 n's here cancel out, just leaving you this thing here. Just leaving you this thing here. And 2 to the power of n is 2n becomes, well, stays as 2n. Okay, so it's just a matter of tidying up. So this thing here becomes this. Okay, and then get this times by itself. Okay, so really you've got n squared plus n over 2 times by itself, n squared plus n over 2. So you've got this thing here and this thing here, top times top. That will then give you this whole thing here, and then bottom times bottom. That will then give you this thing here. Okay, and then it's just a matter of tidying this up. Hang on, let me think. And then it's just a matter of tidying things up. So this cancels out with one of the n's here. Okay, and then the 4 and the 6 here will simplify to 2 over 3. So this gets cancelled out with this, leaving you just the n here. Leaving you just the n here. And the 4 and the 6 will simplify to a 2 and a 3, and so on. Okay, and then this times this will give you this, and then later on we can merge these two. Okay, so it's just a matter of tidying things up. So so hang on. So this and this will merge together to give you this, and what else can we do here? Hang on, let me think. So it's this we simplify with this to give you a 2. Okay, and then blah blah blah. Okay, and then what? Hang on, let me think. And then hang on. This times this. Okay, so that will give you the 4 here, and then bottom times bottom. That will give you, yeah. So when you get to this stage here, it's this times this times this, and then this times this. That will give you 2 here. Okay, this here will become this, and then this thing times the 3 here will become 6 over n. Okay, and then hang on. Let me just move this across, and then hang on. So this times this times this, and this times this, and so on will then give you this. Now remember that our area here is currently approximately this whole thing here. Okay, but then when you start to take the limit, if you take the limit So currently the area here, is approximately equal to this. But then when we start to take the limit as n tends to infinity, so we are having millions and millions of strips as n tends to infinity, then we can say the area is truly equal to this thing here. Okay, so up here the area is only approximately this thing here. But then when you start to take the limit and let the number of strips tends towards infinity, then you can say the area equals this whole thing here. Okay, so it's a big step from the approximate to a precise equal. Okay, so that's when you take the limit and it will be equal to this. So now it's just a matter of working out the limit of this thing here. Okay, so the limit of this thing here will be there's a law that allows you to jump in like this. Okay, so that will allow you to jump into this. That will then become this. That will then become this. Okay, so it's a matter of you finding out the limit of this now. So hang on. So this thing here becomes this. Well, it stays the same. This here, let's leave it the same for the time being. But the limit of this here is really 2. As n tends to infinity, this whole thing here is 2. This thing here will be 0. So, hang on. So that's this 2 here. Okay? And this thing here will become 0. We are just leaving this the same for the time being. Okay, so hang on. Let me go back one step. So from here, it would take us to here. Okay, and then from here it will then take us to here. Okay, so this 2 here, negative 2 here, is this bit here. Okay, so now when you try and find the limit of this here, there are lots of ways of doing this, but we'll break this up into 2 fractions. So you've got one fraction here, and then this here is another fraction, and then break this up into 2 fractions. So this here is one fraction, and then this here is another fraction here. So visualize this whole thing here as 2 separate fractions. Okay, and then you can break into it. So hang on, let me move this, and then now you can break into it. So hang on. So this so the limit of this here, and then the limit of this, and then this bit here will be this. Oops, will be this, and this negative 2 here is negative 2 here. Okay, this thing here will be 0 because if you, as n tends to infinity, this whole thing here, you've got a bubble over another bubble. This bubble here will just be massive as n tends to infinity. This one here will be small in comparison to this n squared. So the denominator will be a lot bigger than the numerator. So therefore the whole thing will tend towards 0. The same reason goes for this. This bubble here will be massive in comparison to this one here. So as n tends to infinity, then you can say that the whole thing here tends to 0. Okay, so hang on. So this thing here will, as n tends to infinity, it will be 4. This thing here, as n tends to infinity, it will be 0. This thing here will be 3. Will be 8 over 3. 8 over 3. And this thing here will tend towards 0. Okay, and then negative 2 here, and then blah blah. Everything will become precisely 14 over 3. Okay.